Now let's build on this to discuss diffusion. So after hearing about concentration gradients, we know that stuff naturally moves from an area of high concentration to an area of low concentration. When particles follow this natural flow of movement, we call that movement diffusion. An example I love to use for this is smoke in a jar. Imagine, if you will, we had a closed jar full of smoke. If I opened that jar, what do you think would happen? Right, the smoke would diffuse out of the jar and into the air. The smoke particles are moving from an area of high concentration of smoke, there were originally more smoke particles in the jar, right? To an area with a low concentration of smoke. There were originally less smoke particles in the air. So the smoke is diffusing into the air. Okay, well, let's take some time now to check in and see why knowing about diffusion is so important and how this knowledge applies to real-life situations. Check-in number 30. If frog eggs taken from a freshwater pond are placed in a saltwater aquarium, what will most likely happen to those frog eggs? Well, let's think through this one together, shall we? If these are freshwater frog eggs, then we can assume that the ratio of water to salt within the eggs is likely close to 1:0, right? Fresh water meaning it's just water with no salt. We can assume this because if the frog eggs thrive in the fresh water, that likely means that they are at equilibrium there with the water. So the percent water outside of the frog egg is likely the same as the percent water inside the frog egg in a freshwater environment, meaning there is likely somewhere close to about 0% salt in the eggs and close to about, somewhere around 100% water, relatively speaking. So that's inside of the eggs. Salt water, on the other hand, if we go to Google and look up percent water in salt water, we can see that salt water is about 96.5% water and about 3.5% solutes, or 3.5% salt. So if salt water is 96.5% water and 3.5% salt, how do you think water will move in this scenario? And then what does this mean for the frog eggs? This actually ties in perfectly with our final topic here, which is osmosis. Osmosis is just the diffusion of water. So if you understand diffusion, then congratulations! That means you also understand osmosis. They mean the exact same thing. The only difference is that the term osmosis refers to the movement of water specifically, while diffusion refers to the movement of any particle, not just water. Now, before we dive into our last check-in questions, I just want to touch on 3 important terms really fast because you will hear these a lot when people talk about diffusion and osmosis, okay? These terms are hypotonic, isotonic, and hypertonic. First things first, all of these terms have to do with something called tonicity, which just refers to the relative amount of solutes if you are comparing one solution to another. So looking at these 3 terms here, let's break them down. The suffix tonic that you see in all of these refers to tonicity. And the prefix hypo means below or low. Think about hypothermia. If you are hypothermic, that means your body temperature is too low or below what it should be, right? All right, moving on to the prefix iso. Iso just means equal, like isometric, which means equal measurements. And finally, the prefix hyper means above or more. If you've ever referred to someone as hyperactive, for example, it's probably because they have above normal levels of energy, or they are more active than the norm. So putting these all together, a hypo solution is a solution with a lower concentration of solutes than another solution. An isotonic solution is just a solution with an equal concentration of solutes to another solution. And a hypertonic solution is a solution with a higher concentration of solutes than another solution. Remember, tonicity, so all of these terms, deal with solutes. Water, just as a reminder, is a solvent. So as the concentration of solutes, such as sugar or salt, as those increase, the concentration of the solvent relative to the solutes, such as water, will decrease. Make sense? So if you had 20% salt in your solution, that would imply there's 80% water. But if that number went up, so now there was 50% salt in that solution, then there would be implied 50% water. So as the solutes go up, solvents go down. Just how percentages work. Make sense? Okay, time for your final check-ins. Here's the scenario. You submerge a cell in a beaker full of a solution made up of 10% sugar and 90% water. The cell is composed of 30% sugar. Answer the following questions. First, what is the percent water in the cell? Is the cell hypotonic, isotonic, or hypertonic compared to the solution in the beaker? And then the same question, but this time comparing the solution in the beaker to the cell. And finally, in which direction would you expect water to move? Into the cell, out of the cell, or neither? Check-in number 32. Same scenario, but this time the solution is made up of 10% sugar and 90% water, while the cell is composed of only 10% sugar. And that concludes our discussion on transport, concentration gradients, diffusion, and osmosis. Awesome work!